Hello everyone, my name is Zhang Shuhan, and today I will introduce the method that I used to solve the question 7 on homework 7. So the question 7 asks us to find the expectation of big E ZT and find the autocorrelation of Z at the time condition of T1, T2, and the third question is to find the autocorrelation of RZ and when T1 equals to Z2. So first, let's focus on the question A, the expectation of ZT. As we can see here, N1 and N2 are WSS, which means the expectation of N1 and N2 is constant, and the autocorrelation of N1 and N2 is only related to the difference of the time T1 and T2. So here we apply the expectation of big ZT and write the expectation like this, and then we can apply the expectation to each part of these equations, and we can get this equation. And in order to solve the expectation of cosine, we need to do a integral. The upper bound of the integral is 2 pi, and the lower bound is 0 because the theta is a random variable range from 0 to 2 pi. And also it is uniform distribution, so the probability dense functions should be 1 over 2 pi. And then we can solve the integral. Since the cosine functions has a period of 2 pi, so the integral of its one period should be 0. And finally, we got the expectation of big Ez equals to 0. The second question is to find the autocorrelation of Rz at time T1 and T2. We just apply the autocorrelation functions, which is the excitation of ZT1 times ZT2. And we write them in details, which is like this. And we apply the excitation to each part of this multiple components, and we get full components of excitation. And since N1, N2, and theta are independent, so we can just apply excitation to each part of the element. So we get these functions. The autocorrelation Rn1 tau, which is the excitation of N1T1 times N1T2, because N1 is WSS, so the autocorrelation is the value of autocorrelation is only related to the tau. Tau is T1 minus T2, which is the difference of these two time variance. And we use the same method to calculate the full components of the excitation, which can be written as this. And like we mentioned about, the cosine and sine functions has a period of 2 pi. So the integral of each sine function should be 0. The integral of the sine and cosine functions should be 0. And we finally get the excitation of ZT1 times ZT2 is equals to 1 over 2 times autocorrelation of N1 times plus autocorrelation of n2 times cosine omega c tau. We can see that these functions only related to the time difference, which is tau, like we calculate on question 1, the excitation of Zt is equals to 0, which is a constant. That is satisfied with the definition of WSS. So Zt is WSS. The third question is to find the autocorrelation of Z when tau equals to 0, which means T1 equals to T2. So we just apply tau equals to 0 to the equations that we solved at the question 2. And we get the final result should be this. To be more specific, the autocorrelation of N10 is the expectation of N1T times N1T, because the T is equals to the T, two T's are equal, so the tau equals 0, which can be written like this. So the autocorrelation autocorrelation of Z when tau equals to 0, the result is 1/2 times the excitation of N1T square times 1/2 the excitation of N2 square. So that's all. Thank you.